Good morning, everyone, and welcome to our AI seminar. Today, I'm going to tell you about how to put AI into production for less effort, for less money, and for less power or electricity power. In today's sessions, we're going to have three speakers, myself, Amar from Oracle, and Steven from Wallaroo. So on the agenda today, of course, we'll be discussing how to productize AI, how to put AI into production. But before we get into that, we're going to cover, what is AI inference versus what is AI training? What are the different requirements for that? What the current state of LLMs is, and that's obviously a wide topic of conversation, and it's changing very rapidly. We're going to cover how to efficiently deploy your LLMs, efficiently meaning for both ease of use, cost, power, and of course, performance. And Steve from Wallaroo is going to tell you how to easily deploy AI workloads on Ampere A1 instances on OCI. He's going to walk you through a demo, and Amar is going to cover what is available on OCI and how you can run your workloads there. We'll cover a bunch of benchmarks, as well as we'll provide some free goodies at the end of the seminar. So first, let's look at AI itself. Well, AI is a fairly bloated term. This can mean anything from robots controlling the world to your traditional machine learning and linear regressions in Microsoft Excel to computer vision on the edge and security cameras to what's lately the generative AI to large language models and so on. The reality is, of course, there's a lot of innovation that went into this space, and it's not fair to say that's all the same. But the one common theme that AI, machine learning, deep learning, or generative AI have together is that as time progresses, as we move from the left-hand side of this chart to the right-hand side of this chart, the complexity of AI models increases, meaning that those models require more data, they have more parameters, they require more training, they require more flops, more operations, more memory bandwidth to run for inference. Essentially, the complexity of those models increases as time progresses. In today's talk, we're going to cover primarily generative AI and LLMs, although similar techniques also apply for, of course, for deep learning and your traditional ML. Second thing, if you look at AI workloads, is that you have two different phases. You have AI training, and you have AI inference. So AI training is when you're building your models, you start with a kind of an empty model, untrained model. You take some data that represents the problem you're trying to solve, and you're building this model to fit into the data that you have available that represents your problem. So that's kind of usually at first that's a one-off process. Inference, on the other hand, is you take that trained model and you put it into production, right? You deploy that model somewhere in your application, where this is a chatbot, as the case today with LLMs, or this is some sort of assistant in your supply chain software, or if this is any sort of advisor assistant in any business process. But net is generally at first at least it's a one-off training process, and then you take that model and you deploy it to hundreds of different devices, applications, or servers for inference, for the actual production. So that's sort of like the initial step. Usually what happens in practice, though, is you have trained your initial model. Maybe you have taken a model off the shelf, kind of a foundational model, or a pre-trained model. You deploy it on your data, whether it's in production or in some test environment. You validate that model. And then usually, instead of training that model from scratch, you make some incremental improvements to the model. You use the process known as fine-tuning. So you fine-tune the model, you improve it a little bit, maybe matches your data better, maybe detects edge cases better, and you take that model and again redeploy it in production. So this process of putting a model from R&D into production, that's usually a continuous process during the life cycle of your application. Anyway, in today's conversation, we want to focus primarily on taking the model from R&D and deploying into production in your application efficiently. And the reason for that is, as Steve will tell you later, is that a lot of models actually don't make it from the R&D to production. But he'll tell you more about that. Second, and that's the second big reason, if you look at the percentage of AI workloads that are inference, about 85% of them are inference. So only 15% of or so of AI workloads are actually training AI training models. And this is the case for both like data center inference as well as edge inference. Meaning that, yes, there's a lot of talk about how expensive model training is, how complex it is, and so on. But the reality is relatively few companies, few developers train their models from scratch. Most of them, if anything, take off-the-shelf model and optimize that model or fine-tune that model for their specific problem. And even then, that step only takes 15% or so of the AI workloads. The actual deployment, the inference, that's the 85% of workloads, meaning that if you look at your, kind of cost structure, complexity structure, needs, you'll be spending 85% of your time putting the model or trying to put the model into production and making it more efficient and scaling that process. So that's why inference is very, very important for us. And that's why we're focusing here on how to optimize inference. Second, and this is something that we have done, so something that Ampere has done, is that we believe in ease of use. Because it's so hard to take a model from R&D to production, we have put a lot of effort into optimizing that process and making it as seamless as possible. So we believe that you should be able to train your AI model wherever you train it, whether it's on GPUs or some other accelerators, in the cloud or on-prem or elsewhere. Train that model and take that model and seamlessly deploy it on Ampere CPUs. And what I mean by seamlessly, I mean by utilizing the same software stacks, by utilizing the same code, by not having to recompile your models, by not having to modify anything in your software stack. So if you look at the software stack on the left-hand side, what most AI developers today face, they have some sort of an AI workload. This could be an NLP workload. This could be computer vision, generative AI, recommendation engine. Maybe it's the umbrella term of machine learning, whatever it is. But most of those models, the vast majority, are expressed or implemented in one of the standard frameworks like PyTorch, TensorFlow, Onyx. And what we have made sure is that you can take those standard AI frameworks, the PyTorches and TensorFlows of the world, and seamlessly deploy them on Ampere hardware, whether it's Ampere 1 CPUs, Ampere Ultra, and others. Of course, on the backend, there's a lot of optimization that goes into those models, that goes into those frameworks, right? You have to ensure the code generated is optimal. You have to ensure that memory layout is optimal, but all of that is abstracted away from AI developers. We want to ensure that the same code written in Python, let's say Python and PyTorch, can run on GPUs, can run on x86 CPUs, but it can also run on Ampere CPUs without having to make a single line of code change. So with this being said, let me give it to Steve to tell you a little bit more about how to make productization of AI models easier and faster.
Awesome. Thank you so much, Victor. And yeah, as Victor mentioned, my name's Steve Notley. I lead our field engineering team here at Wallaroo.AI. And Wallaroo.AI is really a company focused on making that journey from R&D to production as smooth and seamless as possible, and making sure that folks have a healthy production lifecycle once they get there. And this slide right here is really, a big part of our mission statement, right? Gartner published that 90% of AI projects that are being worked on fail to deliver ROI. And this is right in line with what we see talking to customers around different industries with a variety of use cases, and the success rate that they see there. And so why is this, right? And the real answer here is just that R&D and making that leap to production, you're just dealing with so many more differences than people realize, right? You're dealing with a different set of skills that can be needed. You're going from data scientists working in Python, working in their favorite model development environment, to hardcore software engineering, working in tools like Docker, Kubernetes, thinking about things like scalability, right? So a very different skill set, very different set of tools that are needed to kind of bridge that gap, right? Meaning there's lots of kind of back and forth between those different teams to make this successful. There's complexity and difference around the infrastructure, as Victor mentioned, right? Today, a lot of the larger models, especially LLMs, are trained using GPUs. And so folks sometimes assume that that same hardware profile is needed at inference time. And that's something that is not necessarily true, but then raises all of the questions of how can I train on one hardware and make sure I'm optimized for inference on a different set of hardware. In addition to that, just the management layer across all of these different kinds of use cases, from the deep learning, computer vision applications, traditional ML, and all the way out to now Gen AI. How do I manage these things together that may have very different needs in terms of how they get deployed, what goes into that, and how they can actually go ahead and produce that value? And so that's exactly the set of problems that Wallaroo.AI, Ampere, and Oracle have really partnered to solve. And so looking at how we work together, Wallaroo really provides a platform that allows you to leverage those acceleration libraries for AI inference serving, no matter what kind of acceleration you're looking to take advantage of. Ensure that all of the things that Victor had mentioned across these different frameworks, different hardware profiles, are all taken into account automatically when you go to package a model with Wallaroo. We ensure that it's optimized for that Ampere hardware so that you're getting the full benefit of that. And it allows for observability and management in a unified way of these production AI and ML models, so that whether you're dealing with Gen AI models, computer vision models, or a whole mix of them, you can have a single pane of glass and see what your AI stack and AI offerings look like. Combining that with Ampere's CPUs that they offer, which are readily available, they are very efficient, and they are very cost effective, gives you the ability to take full advantage of this hardware, see great performance with it, as we'll talk more about in a minute, and gives you that versatility across all these different deployment scenarios, boiling down to the ability to get this efficient, cost-effective AI inferencing in production with just a few lines of code from where you were at as you kind of finish up your R&D process for a given model. So next, let's see what this actually looks like. We have a demo video here that we can play to start to see what's actually bringing a model, in this case, a version of Llama quantized using Llama CPP, to production using the Ampere stack actually looks like in Wallaroo. And so first, we, staying in the same kind of environment we used to test out our model in a Jupyter notebook, we import our Wallaroo SDK and make a connection to our installed Wallaroo instance. From there, we define the model that we want to go ahead and register. So in this case, it's that Llama CPP model optimized for Ampere. We tell Wallaroo, this is the model, and this is the architecture we want to target, in this case, that Ampere machine. Then we tell it what kind of hardware profile we want to deal with. Again, right in this environment, I can say we want a number of CPUs, we want some amount of memory, and then I want to actually build this pipeline and deploy it with that hardware configuration. And Wallaroo will automate that packaging, that provisioning of the hardware, creation of load balancing and the web service that stands in front of it. And in just a couple of minutes, I'll have a fully ready production grade endpoint that I can use for my applications. And so I send that a test inference, describe what Oracle is in a single sentence. We can see in just a couple of seconds, I get a full response back that accurately summarizes our friends over at Oracle. And from there, I have this external URL that I can start to hand off and integrate in my applications right away. Looking at the Wallaroo Operations Center, I can actually see this model. I can see it alongside all of my others, its status, how I access it, previous versions, what kind of hardware profile it's running on, etc. And this also allows me to take advantage of Wallaroo's purpose-built observability that applies to a wide range of models and includes our novel offering of LLM listeners, which allow you to actually go ahead and score how your LLMs are interacting with your users in production across a variety of metrics. In this case, toxicity and hostile language, to alert us if our model is behaving in a way that we don't like with our customers. And you can see here what those alerts look like, and we have the ability to actually go ahead and dig more into those to correct the behavior of our LLMs in production. And so given all of that, let's look at what we were able to actually kind of achieve here from a more broad standpoint. And so as we'll see on the next slide here, what we were really able to achieve by deploying this Wallaroo packaged Llama CPP quantized model, taking advantage of Ampere's accelerators on OCI's A1 machines, we were able to see double the inference time, or rather double the inference speed relative to equivalent x86 deployments. And so what does that mean? It really paves the way for a lot of these different LLM workloads across different industries to be offloaded to CPUs. And as Victor said, really allows us to do this in a more efficient way, both in terms of power, time, and cost efficacy, while also making sure that we have that unified platform for LLM ops and LLM monitoring. And so with that, if you want to get started, there are a couple of links that we'll make available here in the chat. We do have a managed service here on OCI that gives you and your team full enterprise access to the Wallaroo platform to go ahead and start to try out deploying models. Me and my team are also happy to help in your efforts there. And we also have a free community edition available on OCI as well. And with that, I can turn it over to Amar, who's going to tell you a little bit more about the OCI platform more broadly and all the things it can power.
Awesome. Thank you so much, Steve. This was amazing to see your demo really working and the bots answering the questions the right way. So hi, everyone. My name is Amar Gowda. I'm based here in Seattle. I'm a principal lead for the Gen AI incubations team. So we work with what our hardware should be doing, performing to different scenarios, what are the things, our biggest pain points that our developers and customers are seeing. How do we make it much easier? This space is evolving so quick, so fast that we have seen repeatedly customers come and ask to us, I'm like, okay, I heard about something 3 months back, and is that still relevant now, right? So I think we are still trying to kind of get everybody together to put this as a thing that someone can get up and running as soon as possible. So that's the scope that we are working on. So in the next few slides, I'm going to explain to you what Oracle Cloud has to offer in here and how you can get started quickly, what we call as quick time to dopamine, right? So how do you get up and running? So Victor, the slides, a couple of slides back, if you may. Oracle, the value proposition of Oracle Cloud is, right? So we have plenty of regions, and the regions are much smaller, and the footprint is everywhere, right? So its key thing is about the availability. So the ARM CPUs, especially Ampere CPUs, A1 and A2, are widely available across every region that Oracle has. And right to the smallest DRCC regions, what we call the smallest regions for GDPR and compliance reasons, or as well as regions in APAC, as well as South America. So we don't have GPUs there, right? And we know how much constrained with GPUs we are across everybody, right? So this is where what Victor was saying, right? So we have plenty of customers in Oracle today running foundation model training, right? So they build models with this swath of superclusters that are running GPU heavy. But when it comes to productionizing this and putting this to use, which is what we feel is 85 to 90% of our customers, is to absorb these foundation models built by these large startups and companies and really tailor it to your business needs, right? I don't want the model to tell me the world, encyclopedia of the world. What I care about is for my business, how do I make it relevant and automate some of the tasks that I need to. So this is what we call inference. And for inference, what we have seen is CPUs are extremely efficient. So when we started this journey with Ampere, kind of almost the start of this year, Victor and us, we got together and I'm like, well, what's happening here? What can we do, right? And then we realized that, as things go, people are looking for more availability of resources to do this, as well as being cost awareness, because GPUs are expensive. So they're, especially developers are working with tight budgets, and everybody wants to do a POC to see if this is something the business wants and likes. And for that quick iteration, you're always looking for alternative options. And this is where we felt CPUs fit in very well. And we worked really hard for making the performance, achieve the performance that may be sufficient for your workloads, right? And the last part to it, which always comes back to, is sustainability, right? And GPUs are power hungry. Yes, that is going to be the case with every next generation. And and Ampere happens to be one of the most cost efficient as well as sustainable offering when it comes to the power impact the compute has. So next slide, please, Victor. All right, so what are we seeing in the market today, right? So we talk to a lot of customers, from the ones who build the foundation models to the ones that really productionize everything. And as well as Oracle has a huge business suite and a set of SaaS applications from Fusion, NetApps, NetSuite, and others. So we equally consume quite a bit of internally as well as our customers. What we traditionally were seeing is, right, the biggest models are not that overly popular, right? So we have the biggest models going up to 400, 500 billion parameters. What we've seen is the smaller parameters tend to 8 billion, 8B Llama 3 models to less than 15B models, and the newest models from Llama as well, all of them. Those are the ones that customers usually tend to pick because it's easy to fine tune them and the compute cost that is needed. And they are pretty good with what they do, right? With the responses, the accuracy, and everything else. So this is where, right, there is a pretty much a lot less than 15 billion is what we've seen highest adoption. And we've also seen that these models actually perform really good on CPUs. So this is the trend. And we have amazing scenarios. For example, we were just talking last week to a customer who's looking to, kind of stream all the logs coming from their appliances and devices into an inference endpoint and assess. I'm like, there's a lot of noise in the logs, but I want to just get to the thing, like exactly what is the actionable thing that I need to do, right? So it's from reducing that clutter to exactly actionable things is what scenario is, which is pretty good, right? And we felt it is pretty well fit because you don't have that extra low latency requirement, right? So there's continuous data coming in, and you're running inference, and on a nightly basis or something, someone is looking at it, or what the trends are and what the actionable things they need to care about. All right, so with OCI, what we have done is, right, so is to make developers' life easy, and anyone who wants to get started with Gen AI, with pre-publishing marketplace images. And these are images that are either Ubuntu or Oracle Linux based, and that'll allow you to go quickly find everything. And we package all dependencies for you to run these models. And as well as, you don't have to even go to Hugging Face to download the models. So we have a web UI interface that allows you to go just say, hey, I want to evaluate Llama 3 or Llama 2 or Mistral or Mixtral models, or even other models like text-to-speech models as well, right? So it's kind of made it easy with the web UI interface, so that gets you that quick, proof of concept going, but still allows you to configure, right? These all deployments come with an API endpoint that helps you to integrate with your business applications rather than using the UI that comes with it. So you can go to the marketplace for deployments, and you should be able to find Ampere and Gen AI related stuff. The other part is, right, for someone who does not want to run IaaS and looking for a little bit of a managed service, who doesn't care about patching the systems, keeping it up to date, is a PaaS version, right? Platform as a service. So we offer through OCI Data Science quick actions, which is one of the newest features that came up, that allows you to choose Ampere A1 compute as a shape that you want to run all your workloads on, as well as the Llama.cpp, which is an open source inference engine that is highly optimized for CPUs. And Victor and team and Steve and team, we all work towards further optimizing it to make it the best on Ampere A1s and A2 machines. And this is what you could choose, right? So that is already brings in all the dependencies of Llama.cpp, and what you care about is just like you saw with Steve, right? You are on your Jupyter notebook trying to work with that solution, right? As simple as that. All of the dependencies are pre-packaged for you. The last one, what you saw a demo from Wallaroo, is ISV solutions, right? There are plenty of customers who want someone to manage this, run it, and scale it, and make it much more easier and abstract away all the things that developers should not care about. This is where we have offerings that allow you to go that route as well. And also the observability is another big key thing, because when you scale, when is your machine down, and uptime is equally an important thing. So next slide, Victor. All right, so here's the best thing about it, right? So we've proven that this thing works and this is ready for production. We want you to go and try it, right? And this is why we are extending what we call free credit program, right? So we've gone all the way from a small $300 credit to giving you a full compute, 60 OCPU and 360 gig of single instance of Ampere on OCI. And you folks can go there, register, and one of the representatives will be in touch to how you get access to these instances. And you can spin up that image in the marketplace, or you could as well work with our partners to exactly do the same with either a community offering or a paid offering, whatever works, right? So this is a quick way for you to get started and prove. And also people ask questions about, hey, what the performance looks like. You can see it in real, how the performance really looks. And I think we've done enough performance optimizations where we feel, even working with customers and understanding how much fast is good or slow is bad, right? And we understood that space very well, that we can generate concurrency with a high concurrency, a lot of tokens per second output on a single instance of A1. So with that, Victor, back to you.
Thank you, Amar. So, of course, the resources from Oracle are available. There's a number of different resources that you can utilize where you can learn more about both Ampere and Wallaroo and Oracle combined together. So here's just a few of them. If you click some of those, if you open some of those QR codes, they'll bring you to those websites. So there's our Ampere AI solutions portal that contains all of those benchmarks, libraries, software that you can take and kind of reproduce results and go and run yourself. There's plenty more documentation on this in the second link, the Power Your AI for developers. Of course, there's our GitHub with the model library, benchmarking scripts, demos. So everything that you have seen over here is obviously available. If you're looking to run specifically LLMs and specifically OCI A1 instances, that's a fourth QR code. And lastly, of course, there's the free trial of the A1 instance, and that's also available in the last link. So feel free to explore that. And with this, I would love to open this to Q&A. Happy to answer whatever questions you may have. So one of the questions we have seen is that small size models from Llama and Mistrals have gotten a lot of attention in the LLM space. What are some good use cases for these models relative to the very large LLMs on the market? And Amar, Steve, maybe one of you can take this.
Yeah, I can start, and Steve can pile on it. So the largest model we have seen, we have not seen actually a ton of scenarios yet, right? So we have seen our internal use cases as well as external use cases up to 70B, 80B billion parameter models, because that is sufficient with the amount of content, especially for marketing related automations, right? Think about scenarios like where you're generating a email campaign content based on a set of parameters and profile of your customer, right? So those use cases require you that very high level of accuracy and understanding about a lot of things that matter on how your campaign is tailored together. Those are the scenarios we have seen. But for the smaller size models tend to be much more popular, and this is especially for task automation in internal IT, especially, right? So you're doing like, hey, you're using ServiceNow or any other ticket management systems. You're building a chatbot where it's fine-tuned on top of frequently asked questions. Hey, I'm stuck on this. How do I get past this issue on my Windows, machine that I'm running, right? So those are all things which require you for a chat agent type of thing, which is fine-tuned. The smaller models tend to be more popular because they are very domain-specific built agents, right? And the domain is specifically like an IT side of the things, or Q&A and troubleshooting side of the things. Steve, anything?
Absolutely. Yeah, no, I 100% agree. And we see a lot of the same trends. And yeah, I think that one thing that we see across different industries is that people are really surprised at how much mileage they actually get out of smaller models. We have heard a lot, as more of these models have come out over, the last, couple of years here, that, oh, we're going to start with the small model. We're going to see how it goes. And then as the stuff gets more complex, we assume we'll go up to the bigger models at some point. And the vast majority of customers that we've worked with haven't actually ever found that to be necessary, right? And so we see use cases that are pretty near real-time use cases, things like information extraction, working with documents, image captioning, things like that, to be able to be run in very near real time, even on, with these smaller models and using, CPU-based resources. And so I would say that, yeah, for a bunch of those different applications, even though, if you have an application such that getting an answer back in, a second or two, or getting an answer back in 10 or 20 seconds is, not as big of a delta for the value that you're looking at, the universe gets pretty massive pretty quickly. And to be honest, we haven't found a lot of use cases that we really haven't been able to solve very well using those small models with that.
Just to add to it, right? I don't know if you guys were tuned into what Meta's Connect was, the latest announcement of Llama 3.2 models. They released more small size models, like the 1B model, 1 billion parameter model, 3 billion parameter model, and 11 billion parameter model, on top of others like 8B and others that have come. So that's the trend. You can see that what others are doing as well in this industry and how things are progressing. It's all about making this technology available across any suite of edge devices to, as well as data center devices for particular use cases that fit pretty well.
Yeah, absolutely. Yeah, I think that this also like proves that the optimization of those models is becoming much more important, especially for enterprise customers. All right, everyone. I think we're a little bit past our time. Thank you for the questions. I hope you have all enjoyed this session, and please feel free to reach out to us if you have any other questions. Thank you, everyone.